Hello students, welcome to the second year first semester sessions. Here through online classes we are going to discuss about the course titled Signals and Systems with the course code EC304PC, and for today's lecture we will be discussing about the introduction related to this course. The contents that what we are going to discuss throughout the session are listed here. So we will be seeing the syllabus that is prescribed for us for this particular course in this semester, and then we start with the objectives of the course, what we are going to learn during this, what we are intended to learn throughout this course, and also we will be seeing I'll try to suggest some of those textbooks that what you need to refer to get a clear understanding of those topics that what we are studying here, and the prerequisites that what you the skills that what you require in order to the basic understanding of the subject, so we will also discuss some of those key terms such as a signal and system as an introduction in this particular session. And now coming to the syllabus prescribed for us by the university, the JNTH, as a screen, as you are able to see view on the screen, that the entire syllabus is divided into 5 units, unit 1 to unit 5, and might be this the screen looks with a jargon, a vocabulary of many kind of terms and new terms to you. We might see something related to the function, impulse functions, as well as Fourier series, Fourier transforms, the LTI systems, LTV systems. You might see some kind of convolutions, correlations, Laplace, Z transforms, the sampling and all. This might be very new terms to you, but however don't be panic, we will be coming across each one by one in the coming classes. In the unit 1 we are going to basically study about the signals analysis, where we will be dealing with basic terminology of signals and systems. We will be discussing the definitions of signal, what is meant by a signal and what is meant by a system, their classifications, how do we classify the signals based upon different constraints, and we will also see how do we represent the signals in a mathematical way or in a pictorial way, and similarly we will also deal with the basic signals that what we can actually represent, and we also deal with operations that what we can perform on the signals, and we will also establish an analogy between the known mathematical tools such as vectors, and we will try to see the relationship between the vectors and signals and establish some signal theory related terms in the first unit. And coming to the second unit, we discuss about the Fourier series and the Fourier transforms. Generally the signals are domain specific. We can either represent them in terms of time or sometimes in terms of frequencies. Generally Fourier series and Fourier transforms are the tools or the transformations that will help us in order to change the domain from time to frequency, or either frequency to time. These are the tools that helps us to change them or represent them in either of the domains, Fourier series and Fourier transforms, and we will deal with some of those properties related to those signals whenever we are converting them from one domain to another, and we will also discuss about a new kind of transformation called as a Hilbert transformation there, and we will also see what is meant by a Fourier spectrum, and what leads us to represent what kind of information a frequency spectrum gives us, and why it is very important to represent any particular signal with its frequency spectrum. We'll try to understand these kind of topics in this unit 2, And in the unit 3 we'll be learning about systems, the detailed representation of systems and their classifications, and what do we mean by impulse and step responses or any other responses generally, and what is the speciality of linear time invariant systems, and why that LTI systems are much more important to us. And we'll also see what do you mean by the transfer function, and what are the differences between the bandwidth terms terminology with respect to a signal as well as a system. And we'll also define what are the conditions that we generally require in order to propagate a signal through a system without any noise, that is distortionless transmission through a system. And similarly we will also study about the concept of mathematical tools such as convolution as well as a correlation, and we will also represent their we will also try to find out some mathematical representations and calculations, and how do we generally find out the convolution between any two signals by using graphical means and all in the third unit. And in the unit 4 we will be studying about two other transformations called as Laplace transformations and Z transformations or Z transforms. Generally Laplace transforms are considered as the extension of the Fourier transforms and into the complex domain, and we will try to discuss a little later during this course. And similarly Z transforms are those transforms which are generally used for representing the discrete time signals in terms of frequency domain. And similarly in the unit 5 we generally study about the process of sampling, and sampling is nothing but it is a process of converting any analog signal or a continuous time signal into a discrete time signal. And the sampling theorem actually speaks about the conversion from continuous time to discrete time, and whenever we would like to reconstruct the signal back from discrete time to continuous time signal, then what kind of necessary requirement that we need to take in order to actually satisfy those particular relationships. That means whenever you would like to reconstruct it back, then what we need to do, and different kinds of sampling methodologies that we generally follow, that we will be studying in the unit 5. And also we will study about a mathematical tool of knowing about different kinds of similarities between the signals, that is what we call as an correlation. We will be studying about the autocorrelation and cross correlations. If we would like to know the similarity with respect to the same signal, then we generally call it as an autocorrelation, and if you would like to find out the similarity between any two different signals, generally we call it as a cross correlation. We will also see their frequency domain representation of these particular operations in terms of energy density spectrums and power density spectrums, and the relation between those autocorrelations as well as this power density spectrums in the final unit. And also we'll see certain applications where you can actually detect some of those periodic signals in the presence of noise by correlations, as well as you can also extract the signals from noise, your original signal from the distorted noise signal by filtering. These kind of applications will also be discussed in unit 5. This is the entire a short view on the syllabus that what we are going to discuss in the coming classes. And do not panic, we just go topic by topic, and we try to understand most of the topics from their scratch. Okay, and coming to this course objectives, this course is intended to give a basic information about the signals and systems that is required for studying many of those electrical engineering related subjects. And this also helps us to understand the behavior of the signal in time as well as in the frequency domain. As we have seen, the unit 2 and unit 4 helps us in establishing the relationships with respect to the transformations like Fourier series, Fourier transforms, Laplace and Z transforms. And in unit 3 we generally by studying unit 3 we try to understand the characteristics of the most practical systems called as LTI systems. And overall it gives us the concepts of signals and systems, and its analysis is used its analysis using different transformation techniques. This is what we are intended to study out of this course. And in this modern age of microelectronics, signals and systems generally plays a very important role. It's an extraordinary subject with diverse applications in the areas of science and technology, such as circuit design, seismology, communications, biomedical engineering, energy generation and distribution, speech processing, etc. And therefore it is very essential for us, for every particular engineer or student, those who would like to have a thorough knowledge on this subject. Okay. And understanding of signals and systems is also must for us in order to understand some another courses of engineering in the coming sessions, such as related to analog and digital communications, signal processing related subjects like control systems, digital signal processing and all. Therefore it's very important that every particular student have a thorough knowledge on the topics that what we are going to discuss in the coming classes. And coming to the textbooks that you need to procure in order to have a basic reference in order to understand this subject is, I would like to suggest Signal Systems and Communications by B.P. Lathi, 2013 something after that editions, by B.S. Publications, and Signals and Systems by A.V. Oppenheim, Wileski and Nawabi. This is more like an Indian edition, but however this will help you to generally anywhere after second edition will help us to understand the concepts clearly. And similarly the reference book will be the Michael J. Robert 2008 Fundamentals of Signals and Systems, the McGraw-Hill edition, international edition. This basic textbooks will help us to understand many of the topics related to our signals and systems. Most of the topics in the entire syllabus will be covered in these three textbooks. And coming to the prerequisites, generally any student who's actually attending these courses or listening to these courses, generally as a lecturer or a professor, I expect that every student has this concepts of basic concepts of vector algebra, try to understand what do you mean by a vector, and how different kinds of operations that we perform generally with vectors. And the complex number theory, it plays a very important role in the entire discussion, as well as the basics related to trigonometry, the sine and cos terms, their relations. This might help you to actually deal with some of those real world problems, as well as understanding the basic mathematical theory behind every theoretical topic that we discuss. And similarly the problem solving skills related to this differentiation and integration, the basic calculus, that what you require. This requirement is must, so that you can understand the concepts quite clearly. Done with this, and now let us move to the real part, and we shall start with the course title itself. Let us understand the terminology, the basic terminology about the signal, and what is meant by a signal first, and then we'll also see what is meant by a system. We'll try to understand by the basic notion of understanding. That means whenever we are given with a new vocabulary, generally we tend to relate with what we heard previously. Similarly, let us consider what is meant by a signal. Generally I put this in this way: any time varying physical phenomena that is intended to generally convey information for us. Okay, first of all, I would like to speak about the two terms called as data and information. Um, Data, as we know, that it's an unordered structure of any particular information that uh, what we would like to discuss about. Okay, information is nothing but a processed data. Okay, now signal in its original form is any physical quantity which conveys us some kind of information. I consider it as a signal. Generally, some patterns that what we observe generally, the shapes, the variations, all tend to convey some information for us. If you see a particular different shapes on a blackboard, something like a triangle or a circle or any particular shape, generally, irrespective of their sizes, we generally name them based upon their shape. That means the circle might be a smaller one or might be a very bigger one, but we generally call it as to be a circle. Okay, that means it conveys us information that it is a circle. We are not actually intended whether that shape is related to, that circular shape is related to a cup or a pencil or a pen or something related to a building or any other thing. Okay, we are generally trying to see the shape of it. Okay, and we are not seeing what is this shape actually representing. Throughout this course, we will also be talking about only about this. Okay, and simple examples that I would like to discuss about the signals are the human voices. Okay, so that what I speak, the sign languages, something like a binary language, that what we generally represent in terms of zeros and ones. Generally, when we process those particular sign languages, we generally get some kind of information out of it. Similarly, the Morse code, which is represented in terms of dots, which is used previously in order to share the information. Generally, the Morse code, which is the basis for the radios and telephony, and the traffic signals generally that what we observe on the roads, the red light or the green light or the yellow light, that what it conveys inverse information for us. Okay, they can also be considered to be a signal. And similarly, the voltages that on the telephone wires, the electric fields emanating from radio or television transmitters or the antennas that what we have on the top of our buildings. And similarly, the variations of light intensity in an optical fibers on a telephone or a computer network. These all can be considered some of those examples of the signals roughly, because they carry some information and convey some informations to the receiver. Okay, signals also serves as an important entity for establishing a communication. Therefore, having a broad view on having a clear-cut vision on signals is very important for us in order to establish communications to the fullest. And coming to the system. So what is meant by a system? System can be considered to be a physical device which deals with signals. The system, the physical device, the system generally processes some input signals and produces a output signal. It processes the input signal and produces the output signal. There is a perfect relationship between this output signal and input signal. The processed input signal will be our output signal. Therefore, there will be always a relationship between the output signal and the input signal. And such kind of a relationship is established by our physical device, and we call it as a system. And system might somewhere, it might actually manipulate, or it might alternate the signals, or it might just change the signal, or it might add something to the input signal, but it transforms that input signal so that you will be getting an output signal. That is what we call it as a system. Any physical device which performs this kind of operation where it transforms the input signal and produces some kind of output signal. That means for every cause there is some effect. Such kind of a physical device we call it as a system. And this is a basic understanding of the terminology related to signal and a system. We see that signal is a physical quantity which gives us some information, and system is a device which process input signals to produce us some output signals. Okay, this is a rough idea about that what we are you might have got some rough idea about what we are going to discuss in the coming classes related to signals and systems. And now I would like to deal with some of those examples as we have seen in the case of the signals, generally with the systems. All the scientific instruments such as thermometers or barometers or the odometers that what we use in order to measure the temperatures, pressures and speed, they are all some kind of systems itself, because the thermometer considers the input as our body temperature. That means the body heat is considered to be the input for your thermometer, and it will show try to measure, it will try to show the level of that mercury in your thermometer based upon the input temperature that what we give to the thermometer, and produces some levels which we reads them as the temperature of the human body. And this is how every particular physical phenomena can be related, and we call it as a system. For every cause there is an effect. A physical phenomena which maintains a cause and effect relationship can be considered to be a system. Similarly with respect to this pressure as well as speed and all. And so whenever we see some of other commercial building control systems or industrial plant control systems which actually work with respect to the which they themselves relate with respect to the outside environment. Sometimes some control systems, commercial building control systems, the internal temperature of the building will be based upon the output temperature, output climate. If it is very hot outside, then in the building generally there will be an automatic system where we will be having a controlled room temperature which is very less. Similarly, if it is very cold outside, generally it maintains somewhat heat inside the building. This kind of system based upon the input, we do have some kind of output with respect to the systems. They all can modern farm machinery that what we consider, or the avionics in the airplanes, ignition and fuel pumping controls in your automobiles, in your bikes, cars and all, they are all can be considered as systems because they operate on a particular signal which we consider as an input. Similarly, now I would like to discuss about a communication system which we are which we are going to be very much interested about. In the coming classes we will be trying to, since this is our basic engineering subject, we tend to understand what is a communication system. Generally, every communication system actually considers, it will be having a transmitter which actually produces a signal, and definitely there will be a receiver which receives that particular signal transmitted by the transmitter. And there is a channel, there is a medium which medium for the signal to be transmitted from one end to another, and that is what we call it as a channel. And this is a channel is a path a signal takes from a transmitter to a receiver. Generally, noise is inevitable at all kinds of points, at all the points, something like related to this transmitter, channel or the receiver. Noise may be added at any point. Therefore, noise is inevitably introduced at all points, sometimes only at a single point or sometimes often at multiple points. And this is the information signal that what we induce to the transmitter, so that it process it so that it can be transmitted toward to the receiver, and the receiver receives this information signal. But since due to the induction of the noise at various points, this might not be the original form of the signal, where there is some sort of noise added to the information that what we have passed. We might require some additional circuitry in order to remove those noises, but however, this is the communication system, the basic communication system overall, the transmitter and the receiver. In this particular system that what I have discussed, generally the messages are initiated at the transmitter and the receiver only receives this. This is a particular, something like we call it as an half duplex system, where the message is only transmitted from one end to another end. There might be a case where your transmitter might also act as a receiver at some times, where it can also receive the signals, and similarly the receiver might also be a transmitter. That means this particular devices at both the ends might act both as transmitter and receivers, and in such cases we call such a communication system to be a full duplex system, where both those points act as transmitters and receivers. Okay, this is another communication system and an example of a system that what we are very much interested in the coming classes actually. And similarly, I would also try to explain you about the communication between two people involving signals and signal processing by systems actually. Let us consider, okay, this is a daily example that what we generally see. Let us consider what happens in conversation when one person actually says a word, something like signal, and another hears it. Here the first person is saying the word signal and the another person is generally hearing it. The speaker thinks what I would like to explain the process, what happens here. Actually, this first person is a speaker and the second person is a listener. I use these words now, and the speaker thinks first of the concept of a signal in his mind or in his brain. Then the brain of the speaker actually quickly converts the concept to the word signal. He thinks of the concept, then that will be converted into the word signal. Then his brain actually sends some kind of nerve impulses to his vocal cords, and diaphragm of him actually creates some air movement and vibration, and the tongue and the lip movements of this particular speaker will produce a sound of the word signal. This sound then propagates through the air and between the speaker and the listener, and the sound strikes the listener's eardrum, and the vibrations are converted to nerve impulses back once again, and which the listener brains convert the first to the sound, then the word, then the concept to signal. This is what happens whenever we start a conversation with some another one. Therefore, conversation is accomplished by a system of considerable sophistication here. How does everything is fine here? We have the speaker has uttered a word, something like a signal, and the listener was able to hear it as a signal. But how does a listener's brain know that the complicated pattern is the word signal? The listener is not aware of the detailed air pressure variations, but instead he hears the sound. He or she hears the sound that are caused by the air pressure variations. The eardrum and the brain convert the complicated air pressure pattern into a few simple features. That conversion is similar to what we will do when we convert signal into frequency domain. This process of recognizing a sound by reducing it into a small set of features reduces the amount of information the brain has to process is called as signal processing. And the signal processing and analysis in the technical sense do the same thing that what we have seen here in a more mathematically precise way. Okay, I have just used the words terminology of the signals here, as well as we have also considered some system, the brains of the speaker and the listener, how they actually try to understand the words uttered by some speaker. This is the concept of the entire signals and systems. And for today I would like to end this session here. And today we have just seen the overview of signals and systems, and in the coming classes we detailedly study about the basic classifications on signals as well as the systems, and try to understand the representation of it, operations on it more clearly. Thank you for this.